Okay, people, let's jump into this. We owe a shout out to somebody, an engineer down in Florida, who will remain anonymous. He doesn't want to be harassed by people, but he sent me this image, some images, and we're going to go through them. Thanks a lot. Shout out to you. Let's jump right into the imagery. We're looking at the reinforcement, the rebar here. Reinforcement, and so you can see the staggering spacing. And behind here is the sidewalk. There's a plane of it. I'm going to take that one out. And now this, zoom in. Okay, so how do I zoom in now? Pausing. So as I zoom in here, you see the reinforcement right here. Whoa. Zoom in. You see the reinforcement right there. And then we have the reinforcement further back. We're going to show the, right here up here too, the cones again. Well, I don't know if we're showing what it looks like. Even though this was, on this side was demoed, we're still going to find out what we can in this debris. It's going to talk to us. And part of this talking is it's going to show how this is configured, how this side is configured. There's a sidewalk, there's the bulkhead, and very interesting. You know, the bulkhead is covered over here, but we're gonna reveal the bulkhead. Rebar reinforcement. Let's do this. So I'm going to go here, and I want you to take notice how proud this is. Not bent over, right? Not bent this way. Here's the side, the face of the side, the face. It's not bent that way. And reinforcement, as you can note, right down here and at the very edge of it, you don't see it spalling off. You don't see it fracturing off. Yeah, there's some light rusting stains, but it still looks like it has good grip force, including here. We don't see fractures from spalling, the indicators of spalling. We don't see that. Wow, this is really, really pretty stuff. That's the brace that they use for holding up the wall. It doesn't need help holding it up. Whatever. And let's go. On this image, we'll observe the reinforcement down this wall. See it? You see all the reinforcement down this wall. You'll also observe, going in and out here, the sheet piling, and then you'll take note of what's remaining between the face of the wall, and the sheet piling. Sorry, that was the reverse of that. You'll take note of what's the indentation of the concrete into the sheet piling. You'll take note of what happens when you are at the indentations. And what you observe is that you see these two are proud, sitting right in front of a part of the sheet piling that comes out. So there's not much concrete right there. On this side, there's concrete filling it up. On this side, on the reverse side of it, the business side over here, we see that it has just a little bit of let's come to this one. So there's the sheet piling. And you can see here's our steel. And in front of that steel, or behind the steel here, this steel, and here is just a little bit of concrete between this area and that area. And that's why we see this steel proud like this, not bent over like this. Where we see it bent over, all of a sudden now we have the outgrowths. That's the impression, more depth. And here it was able to break free without bending the steel over. Then we got bent steel, and then we have bent steel, bent steel. And you can see the kind of symmetry of it all the way down. But what you'll note also is that the how huge the sheet piling really is. It's really huge. And this is what they're claiming, that vibration went through all of that sheet piling. Now on that side of the building, we don't know if concrete is on the back side of here. We have to see that. We'll have to observe that. It makes it even more rigid, more composite, more thick, more badass. All right, badassery. How's that? Now you say, why don't they remove the stuff? Well, it's part of the court order, so they can't remove it without a court order. So all this is just staying. You know, anything here that you're inspecting or you're not going to take with you back with court approval to get more testing will stay. Here is a dissection. Just cores. This is not a core. I think that's for something else. Over here we have the floor opened up. With the floor it's opening. All right, right there. It appears not a little bit of water there, but it appears that it's not voided. It's not a void underneath the pad right there. Even though I can't really affirm that because I can't. I can't be sure. I at least in doubt. But normally it's pretty voided. Well, when you see that, but I haven't seen an image like this on an angle. So it's kind of different here. Okay, so there's your pumps for pumping it out, and this is sort of like a septic system for when you're cleaning when you're pumping this water out to wherever they're pumping it to. I think we have a better image of it somewhere else, but it comes into this tank here, overflows this lip. And then from here, it gets pumped out with this line. Comes in with this line, pump out with this line. This should be tested. It tells you what kind of water, whether it's groundwater or whether it's sea groundwater is what I should have been clarify on. Because this is groundwater, but is it sea? Is it brackish water? Is it seawater? All right. For the core samples, they felt the need to core the mess out of this. What's your intent of that? I don't know. Remember, people claiming subsidence, including the architect. It says he's an architect from South Africa, Mike Bell. If you look at the end of his video, he says, and global warming. So, he's one of the global warmers. So, he's a nitwit. So here we are here. I'm sorry, some of you guys invested in global warming. So I don't mean you're a nitwit. All right, you know what I think about global warming. The planet's perfect. It has no problem with getting rid of excess heat. All right, I didn't say pollution, excess heat. Let me keep going. Okay, so here we have the ramp again, the ramp angle. The materials are very interesting here. Right here, these materials are very interesting. I think it's the base. It tells you that they didn't. It doesn't appear to be a engineered material underneath for this slab. That is that it's different materials to make it even more stable. That they went off a reinforcement on the floor to make it from column to column, pier cap to pier cap. I'm going to have a very pretty picture up here on Pier Caps in just a moment. I'll just move this over and let you screenshot, do whatever you want with it. Again, you can see the sampling they did, and I'll make note of their sampling in another closer image coming up. More freehand sampling they did. So let's zoom in. Here's your steel. You see the mouse holding over top of it. And the wall, it's stable down to the floor. Doesn't look like it, it's no fractures or presenting, etc. Now, here are the columns right here. And if you can see, the columns took a huge rotation, right? The machine pawed at it right there, used a paw. All right, that's a paw. At it right there, creating this bending moment right here. And in here, some of the concrete spalled off, fractured off. They dug it out by hand, whatever they did. But there's some of it left at the base. And you can see it at the base where it did not spall off. There it is there, the profile of it. We don't see any fractures off of here. So this is pretty stable. Scene stealer, I saw the image he sent me. This thing has a beautiful pier cap. So these are sitting on this huge pier cap. Scene stealer. Okay, so these are your... well, a building did fall on it, but remember the water, everybody's saying, oh, it's flooded, this place was always had water sitting there, etc. There's your standing water there. Doesn't appear to be much. Probably a pain in the ass if you had on shoes or high heels. So here's your it looks like presented as standing water here per reflectiveness and reflectivity. And down here is interesting. It looks like it's almost set back. You know, it looks like there's more concrete back there. So it's a smooth surface right here. It presents as smooth. I'm zoomed in as far as I can for you guys. Not sure how they did this, but I can tell you it was not. This was not the clean cut. This, see, when you're driving down and it breaks, you get these like this. There's fractures like this, and so I would argue that you know, you couldn't core here because this is fractured by however they removed it. And here again, there's another one, so it's like that. And there's one there. One there. It's really not a clean operation on that one. I don't know what the panic was, that process, but it kind of sucked. Maybe they cut it and it fell down a few inches and they were like, oh shoot, and they had to pick it up. But that's kind of wrong thinking, because I say because this looks like the cap of one of them. That's kind of weird, and yet it's below, presents as below the elevation of the pad up here. So this one has some story to tell, and there's no steel sticking up. That one, I don't know what that clump is in the middle there. I could be seeing ghosts, you know. So there's one in the background with some, looks like almost debris in it. Not sure what that is. Again, these are not clean cuts. This was right here. It's like they might have been clean, and then they used a skid steer or something with the jackhammer on it, and they pried down and try to pry it up. Prying it up, they created this lip right here. This would be this lip here. So it looked like that, and it probably was like that. Might have been a clean cut right here all the way down, and then they did that and they broke off the edge because they were prying from here, and it broke this edge off, this piece off. So they could have anchored it and lifted it out with a crane. It wouldn't take much of a crane for that. They got plenty of budget. They got millions and millions of dollars, but apparently it's no, just go ahead and get it out of there type deal. All right, I might have some conduit in it. Nothing to cry about. Wall surface. Okay, so this is interesting. Let me move it over. Here again, the debris is here, but this shows that they did lift these out. They had a high reach. If you will, a high reach articulating forklift. How about that for you guys? And they probably, with some scaffolding, laid it onto the wall. Laid this wall sections like that and like this onto the sections we see right here, and you can count them and determine how much they can move. 1, 2, 2.5 blocks, maybe total of 3 blocks. Up here, this is more. So it stayed together. You can count them. This looks to be anchored, solid filled, but I don't see any rebar through the base of it. No biggie. And that would correspond to your locations here. It looked like, if I could pretend like I'm looking at it, it looks like there's solid fill there. This looks hollow. See the hollow right there? That wall did behave very well while they tore it apart. This is the slab, and that would be this area right here. You can see it smooth all the way down, and then right on the slab and the tile there, picked up with this color, the color of the wall, see? And then that's the top of the slab. Here's the tile that they kept on site. They kept on site there. They came off pretty easily, so no mastic, if you will. And then there's the wall with my famous blowout that I talk about. Famous, infamous. There they are there. There. And remember, the rebar would be like that. And as this is the rebar 90s. Development length, because this is only 9.5 inches. You probably need 12-inch, 14 inches. Anyway, there's probably 12, and they turned up like that on an angle. Some of them crossed each other, I believe. And created an X. Let's just do that with V's now, I guess. And that would be a 12 inches, 12 inches. That would be bottom, maybe the bottom one. And that's the top one coming over right there, rather. Creating your almost hook design like that at the back. 90s. 290s. And it would look something like that, I'm thinking. And there's your reaction. Remember, your steel is back here. Considering the steel is the same as the other steel of the structure, it's huge. It looks like that. Right? And then your rebar. Okay, so rebar. So let's do that again. So let's do the steel again. And I could overlap over, like right here. Here's the steel below us, right? I could literally just start trying to figure out where the steel is right there. Okay, well, that's there. So that's inside here. So it'll be 2 of them. And I could profile it that way and go, okay, well, where this was, the steel might be proud. And then where it's deeper back like this, so steel back here. Steel here, the back steel and the front steel. And over here, there'll be no back steel because the profile sticks out. I don't think they did that. So this might have, so not right there, but let me clarify that. So let me clarify that. I shouldn't have put it back there. I apologize for that defect. Let me do this. So back steel, front steel, and maybe, the steel back here got chopped. It's in the wall. I believe it's in the wall front and back. But some places, like where it recesses back like this, they allow the double steel, and maybe over here they said, F it. Cut it even with the top here. That could be what's going on. Because I saw some back steel, and in some places I don't see back steel, and so this is what I theorized that what's going on there. And it's just an option. I leave options open, and then until I can get more imagery and more data, and then I go, okay, 100%. They had steel here, and it was sticking up. Once I can see that. But right now, that option is open. That the steel is here. Let me do some front steel now. And I'll do this one. So front steel. So the steel out here at the front of the wall. And then the back of the wall would be this steel. And maybe, like I said, maybe the steel here. Or maybe they cut it even. I think it's 2 layers of steel there in this wall. But maybe they cut it even at the wall plane for the back steel, because it was just not enough cover, and they said, just cut it even. I would think they did not cut it even, that they did that. I would hope that. All right, let's go. Next image. Okay, with this one, I'll end this video. We got more images down below, as you can see, but I'll make another video. Let's go ahead and get the pier caps. Those are the pier columns, and look at these pier caps. They go on top of, so I'll help you see it. It's deeper than that, but there are those piles underneath of it. These things are freaking huge, huge. How are you going to get subsidence and not get these guys moving down? They're friggin' huge. This is beautiful. Much better than this investigation by the courts. So let's just extend that up. There's the columns there. The NIST just came over here and started driving this down with their driver, right? Remember the driver? But remember, excuse me, that this doesn't work doing that, because you okay, there we go. All right, let me change colors, because you have they're trying to see what it will drive down. You've got these 3 piers here. Maybe this is probably a three pier system, so I think this one looks something like this: 1, 2, and 3. Then they put a pier cap on it, which is this pink thing, and then in the center you have your column. All right, there's your column right here. I just did that to show you column. I could do it a little differently. Oops, sorry, it's freehand. And there's your column here, and over here, so this is this column here. And so as they're driving this down with their little test, their big ass weight, their machine, you can see it's just fracturing probably this pier cap, this thing here, this big giant massive section of concrete, just fracturing it. Because it's not going to, you're looking for subsidence, open it up like this. Open it up and take a look at that pier cap. I think they did a beautiful job here. A beautiful job looking at it. Now, this is you can see the soil, the recedence, the tightening, the recompaction, if you will, of the soil by the water around it. But nevertheless, this guy looks like it's right even with the pad. Looks like it's status quo. It looks great. The question I had was, are these pier caps, did they butt up to them, to the columns? I mean, did the floor butt up to the columns? I don't see any reinforcement here. What I do see is black. So it looks like this is the, something that was next to it. I wouldn't say they waterproofed it or anything else, but it appears, darker. And looking at shades and things like that right now. All right, so then so I'm with that. I don't see this fractured out all the way out to here, and you see fractures in this. So no, even with the building coming down, this doesn't present as fractured over here. These don't. I wouldn't expect to see that, because I don't even see fracture here. I know that because this is still here. It would have spalled off had it done that. Had it been that deep. Like here, here's a spalling all the way down there. So again, you would look at I showed you in the first picture, and to see if you see spalling, fractures, to see if it, if it did have any reaction there. Don't see it. I didn't expect to see it. Again, this is a nice, beautiful void here. I don't know if they dug that out and piled, because here's a pile here, and dug it out just to inspect it. I mean, look at all the materials here. So when I said that there's recedence, if you will, well, it's definitely not recedence if we're looking at a stockpile of material up here. This has been dug out, placed up there. Now it's drying. Interesting that they're not, just for the hell of it, testing the load capability of the soil around it. At least I don't see any indications of that. So yeah, that's beautiful. That's beautiful. All right, we'll come back to the rest of the images another time. Wanted to show you this looks like so craftsmanship. This is freehand. See how this and this height is smaller than this height and this height? It was a pop a string line, and they're not even parallel, and then cut and pull it out. This one's got a little waviness to it. Normally there's a machine, you literally bolt to the wall a track, and it would just saw cut, lower it down, saw cut. It's going to be parallel because you put that track on level, and then you make these two cuts. I would think a chainsaw one would be nice here, but they used a large saw because here's your overcuts. Just to be able to collect that, they had an overcut here. The reinforcement shows in the wall here, in the wall system. Up here is the bend over bar we talked about. So here's the bar not bent over. So he would say that would be the flat part. I would theorize that would be this part now. And then I would come out, automatically start profiling whether I like it or not. Okay, that makes sense. These bars look proud, strong. They look like the bars in front of here. So you can start profiling it and saying, okay, look, that's predictable. Samples. That wall's a little shiny, so material sand. I see the column in there. I see you hiding. Okay, I can't tell too much about these granules. I don't know the material down there, but I see the wire mesh that was in here. Looks like top and bottom. Looks like wire, might be wire mesh. See? Doop, 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 doop. Little staggering there. Doop, 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 doop. Little close. That happens. You step on a steel, and that's what happens. Doop. That one might be at the bottom. Doop, doop. Doop, doop. So the thickness of the slab looks pretty consistent. I don't see fractures in this slab. You are at the critical shear zone next to here, so I wouldn't expect that would be a strong section. Don't see fractures on the slab, which is very good. That looks like a fracture. It's at the corner of the cut. I mean, I think it would be a fracture. Again, so you can see that when they poured this, that some was, it looks like that. Okay, and there's your top flat, your finish work. So this is your depth, but even with all that said, no fractures. So, I mean, it's 40 years old, and I don't see fractures along this span. Yet I see top steel, bottom steel, top steel, bottom steel, top steel, bottom steel. It's got traffic in here, vehicle traffic all the way around here, I'm thinking. Yeah, I'm looking down in that little hole there. Okay, we don't see water built up. We don't even see them pumping from there, do we? There's the pump. Maybe they made a low spot in there and down there, and they're pumping it out. Maybe they, dug it so this is low, and the water would just gravitate down there. Maybe this is a little stream from the high spots, so it can dry out while they wait to inspect it, to be able to look at all of this, inspect it. But this looks pretty darn good. Looks pretty nice. There's your cover, the mount over the steel. And there's your bottom steel. Looks pretty nice, doesn't it? Run through real quick. Give you a quick lean. Shoot. Very good. We're good. Yeah. So this is the one where they expose the wall. And I know this may look like it's bad, but the true behavior is this wasn't fractured. above it nor below it. It's anchored to the floor, not going anywhere. Bottle whiskey. Anyway, bottle whiskey. I don't know what that right there. So anyway, this shows the rebar layout in the wall system, and it appears to map with the rebar up top. And there's your spacing, and they appear to be uniform in spacing, whatever this is. So it's 1, 2, 3, and then this should be 4. Maybe I should have went a little higher. 5, 6. So they didn't. Interesting. I mean, were they in a rush? They couldn't finish mapping the friggin' thing down, but we can see it here. Literally see the reinforcement here. But they didn't continue at least a big section over. It might have caused some problems with the wall. You don't want to do that. They left basically some rigidity here. Then again, they did go all the way through the wall here. So this creates a little bit of a weak point. You know, talking about it's probably okay. Just didn't you monitor it? But they did take it all the way out down there. There's some sheet piling there. Remember, this is the same side that the vibration went through this wall system. And yet we don't see the cracks in this wall. We don't see cracks everywhere. And yet this wall, it can fracture a building another 100 feet away, but it just ignores this wall here. I'm quite triggered by that. It ignores all this reinforcement here, no fractures and all. It's a clown show to say that vibration did it. Camera maybe. There are other cameras on this property monitoring it. Oops. Where'd you go? Oh, I guess I didn't. He sent me a quick lot of them. I didn't download them all, I guess. I was trying to show you that they got cameras been monitoring this. So it'd be nice to find out who owns those cameras and make them public. Make these cameras public. That's a camera. Right there. That's a camera. They've been monitoring this. When did this camera go up? Who has it? The courts? Or is it is it public dollars paying for this? Public dollars, you should better get to it. This is all coming out of Surfside's money, the developers' money. Well, it's not public then, isn't it? Even if it's a court. Well, I don't know where that stands with that. All right, I'm a jet now on this one. Hope you guys enjoy this content. We give a shout out to the engineer in Florida there. Thank you. We can't say his name, but we can give him the shout out for all this data. Thank you. Take care. Love you guys. Bye.